So in this video, we were reviewing for our Module 1 tests. Our first two problems we had in class, but I'll just go over them again. So if you understand it, you can skip over this part. But if you want to see it again, stay tuned. So right here it says that figure A, which is the figure that we can see here, is a scale drawing of an original figure, which we do not see here. That scale drawing, it was produced using a scale drawing of 2/5. They want us to draw figure B so that the scale factor from the original to figure B is 3/5. Now, we don't have the numbers for the original, but we need to see about getting those numbers. So if we take a look at figure A, we can see that figure A has a side here of 3, 3, 7, 7, 10, and 10. So I'm going to go ahead and put this information into a table so that we can find our numbers for our original. Now, the original came first because this figure A was a scale drawing of the original. And if we go ahead and put those numbers in that we got in figure A, we got a 3, a 7, and a 10. Also from this work, they tell us that that scale factor to go from the original to the figure A was 2/5. So some number that we don't know yet in the original was multiplied by 2/5 and they got 3. Some number multiplied times 2/5 gave them a 7, and some number times 2/5 gave them 10. So from left to right in this table, we are multiplying, but we don't know that number that's all the way to the left. So we can't do this multiplication problem. What we can do, however, is go the opposite direction and do 3 divided by 2/5, 7 divided by 2/5, and 10 divided by 2/5. So here are those 3 division problems solved for us. So for anywhere we see a 3, the original number was 15 halves, or 7.5, 35.5, or 17.5, and then 50 halves, or just 25. Now I'm going to leave them as mixed numbers, except for the last one. I could turn that into a 25, because that's a straight up even number, or a whole number. But the other two, if I make them as mixed numbers to do my next piece of work, I'm going to have to turn them back into improper fractions. So I'll just leave them as is. So that is giving us our original numbers. So now, according to what I underlined in green here, figure B is going to be created by using the original figure and the scale factor 3/5. So we're going to take those original numbers, 15 halves, 35 halves, and 25, and we're going to multiply it times that scale factor of 3/5. So I'm going to go ahead and take that 15 halves and multiply it times 3/5. I'm going to take that 35 halves and multiply it times 3/5. And I'm going to take that 25 and multiply it times 3/5. So these are now my numbers for my figure B. So we have 4 1/2. We've got 10 1/2. And we've got 15. So that means anytime, wherever I have a 3 in my original figure, so 3 here and a 3 here, that is now going to be 4 1/2. Anywhere I have a 7, that's now going to be 10 1/2. And anywhere I have a 10, that is now going to be a 15. So I can take that set of numbers, 4 1/2, 10 1/2, and 15, and start creating my figure B. So I'm going to go ahead and start off by doing this bottom section right here, where this is right here. So I'm going to go ahead and count off. I'm going to start off with a dot. So here's my dot. I'm going to go up. I have a 3, so instead of going up 3, now it's 4.5. 1, 2, 3, 4.5 tick marks is right here. Then if I go across, it was a 7, now it's a 10.5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and a half would put me in the middle of that box right there. Then I go up, not another 7, but another 10.5. So counting inside the boxes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.5 would be right here. Then to go across to the right, instead of 3, it's 4.5. So 1, 2, 3, 4.5 would put me back where 2 tick marks meet. Then I'm going down, instead of 10, now it's 15. So counting down to 15 would put me here. And then it's 15 going to the left. So then I can go ahead and just connect all my dots to create my scale drawing of this shape. And then I'm going to go ahead and label my numbers. We've got 4.5 here, 4.5 here. We've got 10.5 here, 10.5 here, 15 and 15. And that'll take care of everything that we need to do for that particular problem. All right, the next problem, we're talking about plane A and plane B. They give us some information about plane A. They tell us that plane A uses 21 gallons of fuel to go 609 miles. They tell us that plane B uses 23.5 gallons of gas to go 693.25 miles. So if we go ahead and create our table, I'm actually going to make 2 tables, one for plane A, one for plane B, so that we can compare these things, because they want us to find out, they want us to fill in and make a true statement, which plane uses less gas per mile. So I need to be able to compare these. So we're talking about plane A, plane B. They compare in gallons to miles on both of these planes. And for plane A, they give us the information 21 and 609. And then for plane B, they give us 23.5 gallons with the number of miles being 693.25. So that is going to be our first row in both of these tables. Now, like I said, we answer in part A, they want it to be per mile. So per mile means 1 mile. So to go from 609 to 1, we're going to be dividing by 609, which means to find this number, we're going to be doing 21 divided by 609. So 21 divided by 609. I'm going to go ahead and use my calculator for this one because this is a long decimal. The answer you're going to get is going to be 0.03448. So there's our missing number for that one, 0.3448. We're doing the same thing on this side. To get this number down to 1, we need to divide by 693.25. So doing the same problem, we're doing 23.5 divided by 693.25. Have to move that decimal twice and move this decimal twice. And when we do 23.5 divided by 693.25, another very long problem, and that's going to go 0.03389. Actually, it's 33. We can round it right here, 9. So 0.03, ugly 339. So you can see here that our numbers, we've got 0, 3, 4. This one's 0, or actually that other one should have been a 0 right here. Put my decimal here, not right there. So 0, same number, 3, same number, but right here we got a 4, over here we got a 3. So the question says, which one uses less gallons per mile? That's going to be plane B. This is the lesser number. So plane B uses less gallons per mile. Then the next question says, all right, forget about per mile. What about the planes using 1 gallon of fuel? So now instead of miles being 1, we need to have our gallons be a 1. So now we're going from 21 to 1, so we're dividing by 21. So we need to do 609 divided by 21, and 609 divided by 21 gives us 29. Over on this side, we're doing 23.5 divided by 23.5. So on this side, we're doing 693.25 divided by 23.5. And that gives us 29.5. So the question says plane blank travels blank miles less. All right, so let's see what plane travels less. Oh, plane A travels less. Plane A only goes 29 miles, while plane B goes 29.5 miles. So 29.5 minus 29 is going to leave me with 0.5. So plane A goes half a mile less on 1 gallon of gas than the other plane. All right, so now we got another problem. My suggestion would be to pause this video and go ahead and work this problem out, and then come back and we'll go over the answer. All right, so working this problem out, hopefully you paused the video and came up with your own answer so you know how to do equations. It says the amount Josh charges to mow a lawn is proportional to the time that it takes him to mow a lawn. So letting us know that it's already proportional. For a lawn that takes 2.5 hours to mow, Josh charges the customer $57.50. Which equation models the amount of D dollars that Josh charges when it takes him H hours to mow the lawn? So, just like I've been stressing, tables are going to help us figure this out. So we're going to have our X first, and then our Y, and we need to figure out what we're talking about. Well, we're talking about hours, and we're talking about money. So which one of those do you want to become a 1? Well, obviously, we want the hours, the time, to always be 1. How much money does he make per hour? So if we want hours to become a 1, that means we want it to be our X. So I'm going to go ahead and put my hours here, and I'm going to put my dollars or my pay, whatever it might be, here. So putting those numbers in, we've got 2.5, and then we've got 57.50. So there's our table, and it wants us to create an equation. So if I want to create an equation, I'm going to go ahead with Y is equal to KX. My Y is dollars, but they tell me to use a D for dollars. So I'm going to go ahead and replace the Y with a D. And then it says for hours, which is our X, they want us to use an H. So instead of an X, I'm going to put an H. Now we got to figure out what that K is. K is equal to Y over X. My Y in my table is 57.50. My X is the 2.5. So when we divide those two numbers, 57.50 divided by 2.5, we get a constant of 23. So coming up to our equation, our constant proportionality is 23. That is our equation, which matches up to choice B. All right, this next problem wants us to pick all of the ones that are proportional. So, and select all that applies. So again, pause the video and write down which ones you believe are proportional. Now we're going to go over these. Taking care of the graphs first, you can see that this one, and I'm pretty sure everybody remembers the rules for graphs. This one is not proportional because it is a straight line, but it does not pass through the origin. This one is a proportional graph because it is a straight line and it passes through the origin. Coming up and looking at our equations, anytime we talk about an equation, is y is equal to kx. So a y is equal to a constant times x. That's exactly what this one is. It's never y is equal to kx plus a number. So that is not going to give us a proportional relationship. For the table, we just need to figure it out. We're going to have to do k is equal to 10 over 3. That's our y over our x. And if you do 10 divided by 3, you're going to get 3 1/3. So then we try 5 times 3 1/3. So 5 times 10/3. That's going to be 3 1/3 written back as an improper fraction. I'm going to do some work with it. That's going to give us 50 over 3. And 50 divided by 3 is equal to 16.67 if you write it as a decimal. So obviously not 26. That one is not proportional. Coming over to this side, we can go ahead and see that we would have k is equal to y over x, 4/5 over 1. 4/5 divided by 1 is just going to be 4/5. So we can go ahead and check these problems out. If we do 3 times 4/5, that's going to give us 12 divided by 5. 5 goes into 12 2 times. We would have a remainder of 2. So that one checks out. And then if we do 5 times 4/5, that's going to give us 20 over 5. 20 by 5 is 4. So those numbers check out. That one is proportional. Then we've got our two descriptions. The first description says that the cost of each video game played in an arcade is 25 cents. So there they give us a number. So we would write that equation as y is equal to 0.25x. So that one looks like an equation that we would work out with, just multiplying 25 cents times the number of video games you buy. The next one says your amount doubles every year, but you're starting with $1. So that equation would look like y is equal to 2 times x because you're doubling it. But then you got to add that dollar you started with. Well, that kind of looks like this equation up here, and that one was not proportional. And this last problem deals with the area of some scale drawings. So if you take a look at this problem, it says figure 2 is a scale drawing of figure 1. The area of the original figure, the area of the figure 1 is 20 square units. And the scale factor that relates figure 2 to figure 1 is 3. So that means that figure 1 is our original. Figure 2 is our scale drawing. That also means that this would be our x. This would be our y. And the scale drawing to go from figure 1 to figure 2, the scale factor was a 3. And the only other information they give us is that they tell us that the area of this one, the area is equal to 20. So go ahead and pause the video and figure out what is the area of figure 2. So in doing this problem, it's really simple. If you remember what we did in class, that conjecture that you made up, it was that if you take the scale factor and square it, and then multiply that times the area of the original, you're going to get the area of the scale drawing. So if figure 2 is our scale drawing, that is the area that we're trying to find here. We're going to go ahead and take the scale factor, which is a 3. We're going to square it, and then we're going to multiply that times the area of the original, which is a 20. So 3 squared means 3 times 3. And we're going to take that number and multiply it times 20. So 3 times 3 is 9 times 20. That's going to give us the area of that figure 2. It's going to be 9 times 20, which is 180. So the area of this one is 180 square units. And that is all the problems that, as a review for your tests. So if you know equations, it's going to be a lot of, about 3, maybe 4 problems of building equations and using those equations. Finding the area of 2 figures. The 2 problems that we did a little while ago, the first 2 problems. So 9 questions. Again, most of them I did tables for. Tables are going to really help you out, especially in finding those missing numbers. So just make sure that you use all the tools available to you when you take this test.